All right, so last section we're going to take a look at is 6-2. We'll split that into 2 days. We'll do part today, part tomorrow. And it is on what we call unit circle trig. So let me show you kind of the main idea of what unit circle trig is, and then we'll get into how we do some calculations with it. All right. So let's take a look at this picture. Let's just move some of this out of the way. Okay, and what I've got here is a circle with an XY axis going through it. And I'm going to draw an angle inside that circle. I can draw any angle I want, okay, but it's going to be in standard position. So here's the initial side. Here's the terminal side. The key to unit circle trig is this point right there. The whole goal of unit circle trig is to find where the terminal side hits the edge of the circle. You're going to find the x value and the y value of that point. As the angle changes, that coordinate changes. Every angle on the circle has a unique coordinate that represents it. Finding that coordinate is pretty straightforward as long as the angle you're working with is a multiple of a 30 or a 45. If the angle is not one of those multiples, then this idea of unit circle trig and trying to find a coordinate, it doesn't really work. Right? It's not what it's used for. Okay, so unit circle trig is generally used when we are working with angles that are multiples of 30 and 45. And those come up a lot. Okay, those are angles we use all the time. So any question on what the goal is? The goal is to find that coordinate. Once we have it, then I'll show you what we do with it. So I think I wrote that down. I might just reword it a little bit. Instead of saying for certain angles, I'm going to say for angles that are, and what did I say? Multiples of what?
30 and 45.
Yeah, there's some overlap there, like 90. That's a multiple of both. So for angles that are multiples of 30 and 45, we can draw them in a unit circle. Is it? And I just want to reword how I wrote that last piece. Draw them in a unit circle and then determine the coordinate so remember, you got to find an x and a y. So determine the coordinate where the terminal side intersects the circle. The terminal side intersects the circle. Yeah. Okay. So that's the goal. Yeah.
The circle diagram you showed like a few minutes ago, is that the unit circle?
That is the unit circle. Yep. So that means it would have a radius of what? 1. 1 unit from here to there. So once we find those coordinates, the x value and the y value are going to be plugged into a formula. Different formulas. There are 6 different formulas that we're going to look at, and they each correspond to a different trig function. We're going to look at what's called sine, cosine, tangent, cosecant, secant, and cotangent. Those are the 6 trig functions. Well, at least the 6 that we're gonna study right now. So let's draw our circle and let's see if we can figure out some of the coordinates. I think some angles you should already know the coordinates for. So let's draw Let's start with this angle. What angle does that represent if your point is all the way on the right? Yeah?
0 degrees.
That's 0 degrees. Anybody think they know what the coordinate is for 0 degrees? Yep.
1, 0.
1, 0. Yep. And that never changes. That's always the coordinate for 0 degrees on the unit circle. 1, 0. What's the angle that you get if you draw your terminal side straight up? 90 degrees. And anybody else think they can give me the coordinate for 90? Yeah? 0, 1. Okay. How about the coordinate where your terminal side goes to the left? What's that one? Yep, Caleb.
180.
That's 180. And you think you could give me the coordinate for 180? Say it again.
Negative 1, 0.
-1, 0. And what would be the coordinate where the terminal, where the initial side goes to the right and the terminal side goes straight down? It would be like this angle right here. Yeah.
Like 270?
That's 270. Good. And what's the coordinate for 270?
That'd be 0, -1.
0, -1. So there's 4 points that you already know how to find the coordinate for on the unit circle. There's a total of 16 that we're going to work with. That's 4 of them. The other ones, once we learn them, we really only need to learn 3. And then everything else is kind of like a mirror image or a reflection of those 3. But that's our first 4. 0, 90, 180, and 270. Any questions on those 4 coordinates? So each coordinate that we just wrote down has an x value and it has a y value. That's the most important thing that you have to know. Knowing that the angle you're working with is 180, that's okay. But the important thing you need to know is the coordinate for 180, -1, 0. Without that coordinate, we're not going to be able to do any of these definitions. So these are the 6 trig functions on the unit circle, and they're going to be defined using the coordinate, the x value and the y value of what we just found. If I ask you to find the sine and I give you an angle, like 90 degrees, the first step is you have to find the coordinate for 90. Once you know the coordinate, if I specifically ask you for the sine, it is the y value. You don't need the x value to do sine. Okay, cosine. Okay, if I ask you for the cosine of an angle, the first step is to find the coordinate that connects to that angle, and then tell me the x value of the coordinate. I can't see you moving. The last one is the tangent. So if I ask you for the tangent and I give you an angle, you have to find the coordinate that represents that angle, and then take the y value and divide by the x value. That is the tangent. Okay. Each trig function has a 3-letter abbreviation with it. For those 3, it's just the first 3 letters of each name. SIN, COS, TAN. Okay. Any question on the first 3? So again, just to be clear, this is a Greek letter, right? It's theta. And what do Greek letters always represent in trig? Angles, yes. That's what you plug into a trig function. You plug in an angle. You're not plugging in a side. That would be like Pythagorean theorem. That's a different formula. In that formula, you plug in sides. In these formulas, you plug in angles.
So if we used, in a question, is any other letter other than theta, like any other Greek one, would it still be angle?
Yeah, it can be, it's just a variable, just like in algebra. You don't always have to use x as your variable when you're solving. You can use y, you can use z, you can use m. Yeah, but whatever you plug in there has to be an angle. Okay, so that's our first three, and there's our second three. The names of the second three functions are cosecant, secant, and cotangent. They all use a three-letter abbreviation, except cosecant doesn't use the first three letters of its name. It uses the first letter of each syllable. How come? Yeah, yeah, cosine is already COS, so we can't use that again. Okay, and I'm going to show you, there's a reason I paired these up the way I did. Sine across from cosecant, cosine with secant, tangent with cotangent. Because what's the connection between the sine and the cosecant? Now that you can see the formula. Yeah? Okay, can you be more specific about?
There's only a y in it.
There's only a y in it. Yeah?
Is it the inverse? Or
They're not inverses of each other. But there's another word I am looking for. Yep.
Reciprocal?
They are reciprocals of each other. Yes. So if you know the sine of something, if you flip that, now you know the cosecant. So based on that relationship, what do you think the secant is? Yeah.
1x. Or 1 over x.
1 over x, yep. Secant is what you get when you take the cosine and you flip it. And how about the cotangent? Yeah,
is it x over y?
that's x over y. So there's really kind of a lot of repeat here. They are different trig functions, but they're derived from the originals. You just take the originals and flip them, and that's how you get the three on the right. So you can see every definition there has either an x in it, a y in it, or both. If you don't have the coordinate, you cannot use any of those definitions. So you've got to be able to find these values right there. And right now, you only know how to find them for 0, 90, 180, and 270. I told you eventually we're going to be able to do it for any multiples of 30 and 45. But we're not there yet. So. Okay. Any questions on those 6 definitions? Generally, you're not going to do all 6 in the same problem on the test. I would ask you to do one of the 6. But when we practice on doing examples together, I will do all 6, so you can see how each one works. Okay, so the angles that we talked about so far, 0, 90, 180, and 270, those are called quadrantal angles. They're all the angles that are on the axis.
Like both axes? Axis? Both axes? X and Y?
Well, no, they're only on one or the other. Yeah, 0, 90, 180, and like 0 is on the x-axis, 90 is on the y-axis. 180 is on the x, 270 is on the y. Yeah. So I've kind of been telling you the 2 steps all along to do unit circle trig, but I'm going to write them down formally. So the 2 steps to doing unit circle trig is first to figure out your coordinate. If I give you an angle like 45 degrees, that's not going to help you do unit circle trig. You have to figure out the coordinate for 45 degrees. Now, some problems it says that the coordinate will be provided. If that happens, great. Then you have one less step. You don't have to try to figure out the coordinate. I'm going to give you the coordinate. Okay. So an example of that is example 1a. I'm giving you a coordinate. Example 2, I'm not giving you a coordinate. I'm giving you an angle. So now you have to find the coordinate first, and then you can do step 2. So step 1 is find the coordinate, or if they give it to you, great, you're done step 1. Step 2 is to take the coordinate and plug it into the formula. Which formula? Whichever trig function they want to know. We're going to do all 6. Sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. Now, a couple things that are going to happen, especially with tangent, cotangent, secant, and cosecant. We're going to be flipping lots of fractions. If you ever flip a fraction and you end up with a square root at the bottom, we need to fix it. Okay, we can't leave square roots in the bottom. The other thing we don't want to do is leave a fraction over a fraction. We need to fix that as well. Those two things I just said are not trig. They're arithmetic. Right? Knowing how to divide two fractions and knowing how to fix a square root in the bottom of a fraction. So we'll go through some examples, but we're not doing a whole lesson on that kind of stuff. That's like algebra 1 kind of stuff. Okay. Any questions on those 2 steps? Okay. So let's try this one. It says that they're giving us a point. It represents some angle. You should know what angle it represents. You don't need to do this problem, but can anybody tell me what angle that 0, 1 does represent? Yeah? Yeah, it is 90. Again, that's not what's important. What's important is the location, 0, 1. Okay, so you got the x, you got the y. I want to find the 6 trig functions of the angle represented by this location. Okay, and when I say represented by that location, I mean where the terminal side, if you extend it, hits the edge of the circle. So I'm not going to clarify that every time, but that's what I mean when I say the coordinate that represents the angle. All right, so let's start with our sine. They didn't tell me the angle was 90. We know it's 90, but I'm not going to write in 90. I'm going to leave it as theta because they gave it to me as theta. What's the definition of sine? Yeah.
Theta equals y.
So sine of theta equals y. Yeah. So what would the sine of the angle represented by this coordinate be? 1. Okay. What's the definition of cosine? Yeah. You go.
Theta equals x.
Cosine of theta equals x. So what's the cosine of the angle represented by that location? 0. Okay, so we got sine, we got cosine. How about tangent? What's the definition of tangent on the unit circle? Yes. Y over x.
So it'd be 1 over 0.
1 over 0. Now, you've got to simplify that because I need to know if you know what's 1 divided by 0.
That you can't divide by 0, so it's
0.
Syntax error.
Well, that's what a calculator would say, maybe, or it might say something different.
Undefined.
Undefined, yeah. Okay, so that's the tangent. What's the name of the trig function we get when we flip the sign?
Cosecant.
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 And I just said that you get the cosecant by flipping the sign. So look at the sign, look at the value we got, and flip it. What do you get for the cosecant? 1. Stays the same. Okay. What's the name of the trig function that you get from flipping cosine? Secant. And what do you get? I know it's not a fraction. If you want to pretend it's a fraction, you could just do 0 over 1. What do you get when you flip the cosine?
0.
Nope, the cosine is 0.
Oh, 1.
And we got to simplify that as much as we can. Undefined.
Yes.
Okay. And what's the name of the trig function that you get when you flip the tangent? Cotangent. And what do we get for an answer for the cotangent? Yeah.
0 over 1.
And what does 0 over 1 simplify to? 0. Okay. So those are the 6 trig functions of the angle represented by that coordinate. And again, we know the coordinate is 90, and we know the angle is 90, but that's not necessary to know. Questions on those 6? So it's just plugging the coordinate into 6 different formulas. Let's try this one. What looks different about this coordinate?
The actual numbers.
It's what?
There's bad numbers.
Is bad numbers? What kind of numbers?
There's square roots.
Yeah, so
fractions.
does it look like any of the coordinates that I wrote down right there? No. Then it's not the coordinate for 0, 90, 180, or 270. It is the coordinate for something else, which by on the test, we have to know what it is the coordinate for. But for now, you don't need to know what angle it represents. All you know is you've got a location on the unit circle, and they want you to take that location and find all 6 trig functions. Okay. So let's start with sine. What's the sine of the angle represented by this location going to be? Yep. So 1/2, that is your cosine. Square root of 3 over 2. Okay. Cosine is 1/2. And what's the formula for tangent?
Y over X.
Y over x. What's y in this case?
Square root of 3 over 2.
Square root of 3 over 2.
Yeah.
And Luke, what about x?
X is
1/2.
Yeah.
Now, this is something I told you about earlier. You can't leave a fraction over a fraction. We got to simplify. So, how do you divide a fraction by a fraction? Yep.
Well, you multiply by the reciprocal quantity. So it'd be it's square root of 3 over 2 times 2 over 1.
Yeah. And what happens when you multiply there?
The 2's cancel out and you
Right.
get square root of 3.
Whenever you divide 2 fractions with the same denominator, you can just cancel the 2's, because when you flip and multiply, they would cancel. And what are you left with?
Square root.
Square root of 3. Okay, that is the tangent. Okay, what's the next trig function we're going to do? The one that's up here. Yep, cosecant. Let's write them all down. Cosecant. The one after that, secant. And the last one, cotangent. All right, so at least we know all the names. Now, to get these 3, what do we have to do with the 3 on the left? Yep, flip them. So if you flip root 3 over 2, what do you get? Yeah.
2 over root 3.
So we can start with 2 over root 3. But what just happened there that I said you also don't want to leave that?
You can have a square root as a denominator.
Right, we don't want a square root as a denominator. So does anyone remember what you multiply by to fix it so you don't have the square root in the denominator? Well, you've got to multiply by something that wouldn't change it, because if you change it, then it's wrong. So what's the only thing you can multiply by that won't change it, essentially? Yeah?
Would it be instead the reciprocal? So would it be square root of 3 over 2?
Well, if you multiply by a reciprocal, does that give you a different number than you started with?
It would cancel it out.
We can't do that. We don't want to. We have. What's the only thing you can multiply by that doesn't change a number? 1. So then you have to multiply by 1 somehow, but not 1 over 1.
Is it negative 1?
Is it?
Nope, not a negative 1. What's that?
Is it the square root of 3 over 1?
That's not 1. Square root of 3 over 1 is square root of 3.
3 over 3.
Square root of 3 over. So square root of 3 over square root of 3. Okay, so you're multiplying by the same thing in the top and the bottom, so you're not changing the value. You are making it look different. It's like writing something as 4 or 8 over 2. It's the same thing. They just look different. What do you get when you multiply straight across?
2 times the square root of 3.
2 times the square root of 3. And in the bottom? Yeah. 3. Yeah, square root of 3 times the square root of 3 is 3. Yeah.
Is that because it becomes the square root of 9?
Yes.
And then that's 3.
And that's 3. Yep. So 2 root 3 over 3. That is your cosecant. How about the secant? What's that going to be? Yeah, 2. 2. That's an easy one. There's no roots. And cotangent. Okay. Just give me the first step, and then if we need to fix it, we'll fix it. So what's your first step to finding the cotangent? Yep.
Just put in fraction 1 over 2 or square root of 3 over 2.
So tell me again what you'd have right here.
The top is 1 over 2.
1 over.
2.
So we want to be looking at this, because that was our final answer.
Square root of 3.
Square root of 3. Yeah. You're not going to end up with any 2's in this problem, because all the 2's canceled out. So we don't have to worry about anything with it, too.
Sure.
Yep.
I thought that the cotangent was x over y.
So that's, yeah, it's the reciprocal of tangent. And that's what I did right here. I just took tangent and I flipped it. But why reintroduce the 2's again? Because then they're just going to cancel again. So it's easier to work with the final answer that you had after you cancel the 2's than to go back to the original problem. So we flip tangent, we get 1 over root 3. And what do I multiply by to fix that one? Yep, Christian.
Square root of 3.
Yeah, it's got to be the same thing in the top and the bottom. And now multiply straight across. Yep. Square root of 3 over 3. Okay, so that would be like 6 different questions. That's what we basically just did, 6 problems. Okay. Once you start to get faster at it, there's not a lot of variation in the numbers that you see. You have root 3 over 3's, 2 root 3 over 3's, 1/2's, root 3 over 2. You could have any of the numbers I just said with a negative. But that's pretty much it. Right? When we're dealing with 30's and 60's. These are pretty much all the different answers you'll ever see. Okay, when we deal with 45's, those are actually a little bit easier. Coordinates are not as bad as this one. But, anybody have an idea what that is the coordinate for? 1/2 root 3 over 2.
That's a good question.
Anyone have a guess? Yeah. Well, 70 is not an angle we can really do on the unit circle. The only angles we can work with on the unit circle are multiples of 30 and 45. And you know that the x and the y value are both positive here, so that tells you the quadrant it's in.
Is it 45?
It's not a 45 because with the 45, you go over and up the same amount.
Is it 30?
It's not the 30.
Okay. That's all for me.
60.
It is a 60, yeah.
Whoa.
That's the coordinate for 60 degrees. So we'll learn why that's the coordinate for 60 probably tomorrow.
What quadrant would 90 degrees be considered?
90 is not in the quadrant.
It would just be no quadrant, or would it be one and?
You would say it's on the y-axis.
Okay.
Yeah. All right. So that's that one. Let's try this one. Find the 6 trig functions of 90. Okay. What's different about this question than the last two?
You're already with theta.
Yeah, we know theta now. We know the angle. That's not what we need to know.
Wait.
What is it that we need to know about theta? And if we don't know this, we're not doing unit circle trig. Yeah?
The coordinates.
Right, we need the location of 90 degrees. So if you're not sure, you can write that down. You can draw a picture. 90 is when you go straight up. And what's the coordinate on the unit circle when you go straight up?
0, 1.
0, 1. So now we're doing all these trig functions with an x value of 0 and a y value of 1. But we just did that. So example 2 is the same as example 1a. The only difference is you had to find the coordinate first, but all the answers are exactly the same. It's the coordinate 0, 1. Any question why they're all going to be the same? All right, let's try 6 trig functions of 270. We haven't done this one yet. So if you're not sure what 270 is, visualize the circle. And where's 270 on the circle? It's at the, yep.
0, -1.
Yeah, it's at the bottom. And when you're at the bottom, it's 0, -1. Okay, so now find your 6 trig functions using x and y. What would be the sign of 270? Yep.
Are you asking for the number itself?
Yep, whatever was going to go in that box right there.
-1.
-1. How about the cosine of 270? Remember?
0.
0. Yep. And the tangent of 270? Yep.
-1 over 0.
And what's -1 over 0?
Undefined.
Yes, undefined. If you leave it as -1 over 0, I'll give you half credit because you did know the formula, but I don't know if you know that you can't divide by 0. Okay. So -1 over 0 is undefined. All right, cosecant of 270. Yep.
1 over -1.
And what does that simplify to?
Nope, I don't know.
-1.
Thank you.
So we get -1. How about the secant of 270? Final answer? Yep.
Undefined.
Undefined. And what about the cotangent of 270? Final answer. Yep.
Undefined.
If something starts as undefined, when you flip it, it doesn't stay undefined.
Oh.
There's only 2 numbers that you can flip and they stay the same. That's 1 and -1. Undefined becomes something different. Yep.
0.
0.
Right, so right there.
Because the cotangent would be 0 divided by -1. 0 in the top of a fraction, -1 in the bottom, comes out to 0. Any questions on that? So this is pretty much what you're doing when you do unit circle trig. Let's try this one. 6 trig functions of pi. What's a little different about this one? Yeah.
It's pi for theta.
Yeah. What does that mean?
It doesn't stop. Like the number pi.
No, that's a value. It's 3. I mean, it does go on forever, but it is a value that we know the coordinate of. Yeah. It's in radians. Yeah. So what is that? Pi. Yeah.
Oh, 180.
That's 180. So now just ask yourself, what's the coordinate for 180?
What?
-1, 0.
-1, 0.
So anytime I see pi, I think 180.
It's because it's in.
If you
it's
convert
in
it properly, you
radians.
should.
I'm gonna write.
Yep. Pi is 180. It's like anytime you see 36 inches, you should think 3 feet. Why? Well, that's the definition of 36 inches. It's 3 feet.
Okay, I like that.
So pi is 180. It's the definition. So -1, 0. And now we're doing the same thing we did the last 2 problems. I don't think we've done -1, 0. Nope. Yeah. Okay. So what would be the sign of pi radians? Yep.
0.
0. The cosine of pi radians? Yeah. -1. And the tangent of pi radians. Just imagine putting a division line right here. That's tangent. 0 over -1.
Oh, wait, 0.
0. 0 divided by -1 is 0.
Gotcha there.
Okay. How about the cosecant of pi radians, Julia? Undefined. The secant of pi radians. Yep.
What? No? Okay. 0? No? Okay.
What trig function are we going to use to help us find secant? Tell me that.
It's 1 over.
So-
Sorry.
So what trig function is that?
Is it not secant?
Well, we're looking for the secant, but what trig function do we use to help us find secant? Yeah,
Cosine.
cosine. And what do you do to the cosine?
Flip it.
Flip it. So flip the cosine. What do you get? -1.
Beautiful.
Okay, and how about the cotangent? Yep, Julia? Undefined. Okay, any questions on those 6? Let's try this one. 6 trig functions of 7 pi over 2. Eventually, we're not going to keep doing all 6. We're going to probably do like 3. It's time consuming if you keep doing all 6.
Yeah.
What's going on here? Yep.
I have a theory. Are we gonna like multiply the 7 to the x and then multiply the 2 to the y, or am I dumb?
Well, what is that? What did they give me?
Fraction?
A fraction? And tell me more about it.
There's pi in it. I don't like it.
Yeah,
It's a radian.
it's in radians. If you're not comfortable with it in radians, then you need to change it to degrees.
It's bigger than 360.
Might be. We'll see. How would you change that to degrees?
Oh, would you?
Multiply?
Multiply by 180, divide by 5.
Multiply by 180, divide by pi. Now, this isn't finding what they want yet. This is making it easier to figure out the coordinate. If you know the coordinate of 7 pi over 2, you could skip what we're doing right now. If you don't, then you're probably going to have to change to degrees and then figure it out. What happens when you multiply there?
Do you want the final answer?
Just kind of guide me through it so people can see where the final answer is coming from.
Well, you can cancel out the 5, and you can do 2 goes into 80 90 times. Like that's 1, and that gives us a 90, and then 90 times 7 is 630
Yep.
degrees.
90 times 7 is 630. So at least you have it in degrees, but that's still not an easy angle to work with. What can we do? And we talked about this earlier in the week. Something we can do to that number that will not mess up any of these 6 trig functions. It's going to change that number, but it's not going to mess up the answers. Yeah?
Well, this is easier to subtract, that's like 360.
Yeah.
So you get a number below 360.
Subtract 360. So what we're working with this time is a 270 degree angle. Now, what's the coordinate for 270? Which is also the coordinate for the original problem, 7 pi over 2. Yeah.
0, -1.
0, -1. But we already did 0, -1 in example 3. So this question is the same question as example 3. It's just written in radians instead of degrees. Okay. Any question why it's the same? So see example 3. Yeah.
I was just wondering if I plugged in like the 7 pi over 2 with the 180 stuff, would I, like if I plugged it into a calculator, would it give me 630? Because I'm not going to remember that.
No.
Aw.
No. If you plug sine of 7 pi over 2, it wouldn't give you 630.
No, I mean like with the 180 pi.
Oh,
like,
it gives
times
you-
It's still, what,
Oh, it gives you a very small decimal.
Why?
yeah, that's what it is, and that's the decimal.
So you have to know how to do that. Yeah. You got to know how to change radians to degrees,
Okay.
and then add or subtract 360 if you get an angle that's too big or too small.
Okay.
But all these answers are going to be the same as example 3 because the coordinate is 0, -1, and that's the same coordinate we just did. How about
It did give me negative.
this one?
What?
When I plugged it in, it did give me
What's
negative.
the 6 trig functions of -90? Again, that's not an angle we want to really work with, so we should fix that first. Yeah.
Wouldn't that be the same as the last one?
Yeah. If you add 360 to that, -90 plus 360 is 270. It's the third time I've asked the same question. It's 270 degrees. The coordinate is 0, -1. So it's the same as example 3, which is the same as example 5. That's why I said there is a lot of repetition because there's only so many questions you can ask on a unit circle. And then after a while, they start to repeat.
I like that.
Even if you write it differently, it's probably the same as something else you've already done. Okay. So any questions on that?
Hamburger.
Okay, so the last thing we're going to look at, and we're not going to finish this. We're going to get through probably one question on it. Is 6.2 part 2. When I've asked you to find a coordinate so far, what are the angles that I've had you work with? We've only had 4. Every problem has always been one of these 4, even if it looks like it's a negative version of it or a radian version, it still boils down to one of these 4.
0, 90, 180.
Yep, 0, 90, 180, and 270. So in part 2, we're going to look at finding the trig functions of angles that are multiples of 30 and 45. Those are the other angles I told you can do on the circle. And we've already seen a coordinate, and we've already worked with a coordinate that was a multiple of 30 and 45. We worked with the 60. We didn't know that this was 60, but I told you that this was 60. So you've already seen the arithmetic that you're going to have to do with the 30s and 60s. It's this. The only thing is you didn't know what that actually was the coordinate for. Now, you're going to have to know how to figure that coordinate out. So we're going to work with angles that are multiples of, this is 30. This is 60. That's kind of redundant because if you say something's a multiple of 60, it's automatically a multiple of 30. And multiples of 45. So we'll start with the 30, 60, 45. And once we know those 3, then the multiples are very easy. Like 120, that's a multiple of 30. 150, That's a multiple of 30. Okay, so this is very similar to what we've been doing all along. It still involves figuring out a coordinate, plugging the x and the y into a formula, and then getting the answer. The very last thing we'll look at is kind of an introduction to trig identities. You've already seen some identities in the last section, like the fact that you can take the sign and you flip it, and it gives you the what?
Reciprocal.
But what do we call it? The cosecant. The fact that you can flip the sign and get the cosecant, that is an identity. An identity means it works all of the time.
When did that?
It's not like you can only flip the sign if the angle is an even number, or if it's an odd number. No, it works all the time. You take the sign, you flip it, and you get the cosecant. Okay, that is an identity. So I'm going to kind of formalize that a little bit towards the very end of the section tomorrow. All right, so let's look at the only angle we're going to do today, which is a 45. So here's 0. Here's 90. We already know the coordinates for those. And I put a dot about where I thought 45 was. The goal, if you want to be able to find the 6 trig functions of 45 degrees, you've got to figure out that x and that y value. Now, what's the radius of this circle? 1. So do you think the coordinate of 45 would be 1, 1?
Oh.
No.
No. Because if you did 1,
Be
1,
up in like the corner.
1, 1 is off the circle.
It's more of like where the 5 is.
Yeah.
There's a line at 1.
Degree is.
Ooh, so is it like half?
4.75.
There's a line at 1. So 1, 1 is over here. So it's not 1, 1. It's, well, half would be kind of like right in the middle of that box I just made. So it's a number that we got to figure out.
We should just measure with a ruler.
We could try, but the ruler won't tell us.
0.75.
It's a number that has a square root in it.
You don't know rulers like that?
Yeah.
I've heard you twice.
Okay.
Gabby said it.
I did? Me?
No, we both said 0.75.
Well, it's not. It has a square root in it. So it's actually kind of close to that number, but it's not exactly
You
that.
lost me.
Okay, so we're going to take what we have there and we're going to turn it into a shape to help us figure this out. Anybody have a guess what shape I can make out of the diagram I have there? One of the sides of the shape is already there. Actually, kind of 2 of the sides, but I need one more thing to make this into the shape I'm thinking of. Yep. Yeah, we're going to make it into a triangle. And the way we're going to make it into a triangle is draw a perpendicular straight down like that. Now, what is the x value of this coordinate in terms of that triangle? The x is the what?
What is it?
So what is the x value of 45 degrees? I'm not asking for the number. I'm asking like what it represents. Something in this triangle
Where?
represents the x value of 45 degrees. Yeah.
Where it is.
Yep.
So I'm asking like something about the triangle itself. Yeah.
The line on the bottom?
What about the line on the bottom?
The length of it?
The length of it. Yes. If you can find the length of the line on the bottom, that is the x value for the coordinate of 45 degrees. It's how far to the right you have to go. And then what about the y value?
Is that the?
Yep.
That's all it is.
How tall it is.
Yeah.
That's your y value. So if we can figure out, this is all going to just come down to measuring a triangle. Find the length of the bottom and find the length of the height. But we know that this triangle has a 45-degree angle there because that's the angle the hypotenuse is tilted at to point at 45. So what would this angle at the top have to be? Yeah.
45 also.
It's also 45. So that's a 45, 45, 90 right triangle, and that tells us something about the triangle.
Oh, wait, never mind.
It tells us a few things, but what I'm looking for something particular. particular. Yeah.
This is geometry.
Okay, what about the hypotenuse?
Well, I have one.
Do we know the hypotenuse?
What is that?
Hypotenuse is line.
Yes.
Is the what?
I think we do.
Line.
You should know.
Don't
Line,
remember
yeah.
it, but I know because
Well,
like
I
it's a
think
right.
A squared plus B squared equals C squared. And
You're not going to need anything. You're going to need that, but not yet.
Bro, remember this one from geometry.
So what do you know about that triangle? Tell me anything you know about it. That's helpful. Yes.
Oh, right. That's helpful. I was just gonna say it's a right triangle.
It is a right triangle.
That's helpful. I'll take it.
Yeah.
Isn't aren't the x and y sides equal?
Why are they equal?
Because it's the same angle from both of them. I'm not
They're
sure.
across from congruent angles, so yes, the x and the y have to be the same. Same.
Geometry.
Okay. What kind of triangle does that make it?
Right triangle.
No, if two sides are the same. It's more than that. It's isosceles.
Yeah, the sausage.
Okay. So, because we have an isosceles triangle, we don't need to use two different labels. If you use two different labels, like we did there, x and y, you're saying that the sides are different, right? They're not different. So let's just use the same letter to represent the base and the same letter for the height, because they're the same. That way we don't have two different letters in the problem. So what do we want to call the base?
X,
Okay, then what are we going to call the height?
Y,
X.
Y.
X.
What? Oh.
What?
You just talked about
Sorry.
That was the whole thing I was trying to get at.
Right, because it's isosceles. Don't use two different letters unless the sides are different. They're not different.
I got you.
But there's something else we know there too.
Y. No, C. No.
Somebody tell me something else I know about that triangle.
That's tough.
The angle.
It's the only thing not labeled.
The long line.
The diagonal.
How long is that?
Wait. Wait.
Wait. A squared plus B squared equals C squared, so it'd be X
So it's X
squared.
squared.
Well, we'll talk about Pythagorean theorem in a minute, but you can't use Pythagorean theorem unless you know that third side.
Oh.
Because right now it's unknown. You can't plug an
No,
unknown.
equals C squared. And that's C, isn't it?
Yeah, but we know the hypotenuse.
X squared plus x squared equals.
No, it's
Oh, is it
numerics.
90?
Equals the
It's
square.
I'm lying.
Yeah. It's 1. Why is it 1?
What?
Oh my god, does that
Oh,
make
the line.
Oh.
It's the radius in that circle.
Wow.
It's the line from the center to the edge.
Actually, doesn't make sense.
Big radius.
So now that we know that that's 1, yes, you can use Pythagorean theorem because you've got one letter. It's used twice, but that's fine. It's just one letter, and we'll set up Pythagorean theorem. How would you set up Pythagorean theorem for this problem using information in that triangle? Yep.
1 equals
So I'm just going to do 1 squared, which I know is 1, but 1 squared,
X squared
x squared,
times 2. Maybe? I don't know.
Plus x.
Plus X squared.
plus x squared, which does come out to times 2.
Tell the guys 2X squared.
And now our goal is to get x by itself. What's the next step? Yep.
Divide by 2.
Divide by 2.
Luke, I'll let you get the next
No, it's
one.
okay. It's okay. I can think you're already
Hold on,
there.
where did this?
And
He doesn't know it.
So when we divide by 2,
Where did the square go on the one?
1 squared is just 1.
Oh, okay. Thank you.
Yep. And now we still need to find x. So what do we have to do now? Yep. And when you square root a fraction, you square root the top, and you have to square root the bottom. Okay, but you need to simplify that as much as you can. What's the square root of 1? Well, that part's easy. But the square root of 2, does that come out to a nice number? No. So then we just have to fix it so we don't have the square root in the bottom. And that's our answer for x.
So it's just
like that.
by square root of 2 over square root of 2.
Yep.
Oh.
Okay.
Multiply by square root of 2 over square root of 2. So again, nothing here is stuff that I taught you. This is all Pythagorean theorem and fixing roots in the bottom of a fraction. Once we get this answer, then I'm going to show you the part that I showed. So what do you get here?
2.
Square root of 2 over 2.
It's that easy.
Yes.
So not 2.
Is that our x value?
That is our, well, that's the length of the bottom side. Yep.
So then it would be, okay, so x equals.
So that's the length of the bottom, but it's also
Or y.
the y.
Yes.
So let's write that is y.
Mr. Clark.
So
Two
what
lines of me.
what would be the coordinate for 45 degrees?
Oh, I don't know.
How far?
I know.
How far over? And then how far up?
The red, the
Yeah.
square root.
Square root of
Same.
2 over 2, and then your y value would be the same thing.
Yeah. So that is always the coordinate for 45 degrees. Now that we have that coordinate,
Right.
we don't want to have to go back through and figure it out. Okay, we have it. That's just something we want to memorize. 45 degrees always has an x value of root 2 over 2 and a y value of root 2 over 2. And it's not hard to see where it comes from because it just uses Pythagorean theorem. That's all it uses. So if you forget it, you could figure it out again each time. But it's going to take too long if you have to keep figuring it out. So just memorize that. Okay. So let's just do 2 of these. What's the first thing you'd have to know if I asked you about a trig function and I give you an angle?
You gotta know the coordinates.
You need to know the coordinate that represents that angle. If you don't know it, you have to figure it all out from scratch. Or, if you memorize it, that makes it a lot easier. What's the coordinate for 45?
Square root of 2 over 2. Square root of 2 over 2.
Square root of 2 over 2, square root of 2 over 2. So what would be just the sign?
Square root of 2.
Yep, which one? Just so I know which one you picked. The y. Okay. So from here, everything's the same that we've been doing. We're just using this for x and use that for y. What about the tangent? Yep.
Square root of 2 over square root of 2 over 2, which we can't do that. So we gotta do something else.
So that is how we want to think about it, but yeah, we got to simplify that. Yep.
That's all you.
So if you were to elaborate on Gabby's, you can't see that, it would be square root 2 over 2 times 2 over the square root of 2. After you flip them and do the reciprocal. But it's going to be weird because then you get a square root at the top and the bottom. Wouldn't it just be 1?
Yeah. Oh yeah, wait.
That actually does make
It would
sense.
be 1.
Because the tangent is the y value divided by the x value. They're the same. So when you divide two things that are the same, you get 1.
You alright?
Okay. So that's the 45. And then tomorrow we'll review the 45 a little bit when we go over the homework. And then we'll do the 30 and the 60.
The is so bad.
The 30 is going to be horrible.
Do I have to do it right
Oh.
Ew. What the?
Why are those there?
So
What's up with that?
on page 335, I got to add 2 questions. We did something different. I want you to do 1, 5, and 8, which is finding a coordinate. Then I want you to find the 6 trig functions of 1, 5, and 8. So after you get the coordinate, do the 6 trig functions. And I want you to do the 6 trig functions of these 3. This one, I'm giving you a coordinate. We actually already did 2 of them a minute ago. Root 2 over 2, root 2 over 2.
For a second, I thought you were giving us like the numbers.
Yeah. You gotta figure out which problems you're gonna do.
That's what I thought.
No, that's just 45.
Numbers you get things
So it's 1, 5, and 8 in the book. 14 and 22 is also in the book. And then I want you to find the 6 trig functions of 1, 5, and 8. And the 6 trig functions of, well, you're going to have to figure out this coordinate and this coordinate. But I think we've already done them in class.
So just go into our notes.
So that's the homework for tonight.